Shawn, thanks a lot. Welcome. I think that you can go straight. The floor is yours, and I think you can tell about yourself for people that doesn't know you. And thanks again, Pete, for your presentation.
Yes, thank you, Marcelo. Just so you know, so it's about 7:30 my time here, 7:45. So if you see me sipping on some coffee, that's why. So I
Okay.
apologize if I'm like continuing to like inject myself with caffeine, but I'm super happy to be here. Thank you for having me on. As Marcelo mentioned, I am a senior developer relations engineer with Edge Impulse. I've been there for about 2 years, and I help write tutorials, teach, make videos. I just released a what is Edge AI video, very high level. Like any of y'all probably know all the stuff in it. It's mainly for like companies and industry, or companies and executives who may not understand what this is and where it's going. But I also help run the university program, which includes giving content. We used to do an Arduino giveaway to help schools ramp up to speed. We're not doing that this year, unfortunately. But like just helping people understand what this new technology is, get that information out there, and inspire people with things like projects. Is there a way I can share my screen? Let's see. I'm assuming there's a share screen. Yeah, I'm used to we
Yeah.
use Gmail video, so I want to share this one. Bear with me for 1 second.
Yes.
And Marcelo, I'm good to go on the presentation, right?
Yes. Yes. It's better if you put in the presentation mode, but yeah.
Got it. Sorry, 1 second. Large, is that what I'm looking for? Nope.
No, it's okay. I think you only to use a slideshow is okay.
The slideshow, yep. I'm trying to figure out where the zoom button is because I liked having the chat. As soon as I went to like share screen, it's sharing
Okay.
screen. Right. If anybody knows how to get oh, there it is. It's like a chat window. Yeah, because if somebody has a question, I want to keep an eye on that.
Mm-hmm. But I can
Um,
help you, Sean, if some questions appears here.
fair. No, that's totally fair. Yeah, if questions come up, I hope to make this somewhat interactive. So if you have questions as we're going, I'll try to stop and answer some. And then if I've missed any at the end, I'll time permitting. I think I've got about 45 minutes for this. So, and everyone, you can see my screen, right? We're good.
Yeah.
Sounds good. All right. So as I mentioned, I'm going to describe what Edge Impulse is. If you haven't heard of us, you haven't tinkered with it, I'll give a demonstration of a project I threw together using a sample data set that we have. And then I'll walk you through, like show you kind of where all the stuff in Studio is in case you haven't seen it before or you want to use it or teach it to your students. And then go through some of the new features in Edge Impulse that we've released in the last year, as well as demonstrate, like just go through some fun projects that community members and students have put together, and two of the ones that I have done for fun. And then any remaining questions we have, I'll go into that. So Studio is our main product. It is a graphical interface, web-based. You access it through a browser. It's a backend system is used for collecting data, training machine learning models, deploying those machine learning models to edge and embedded devices. And that includes everything from like Linux to GPUs, we have Docker containers now, all the way to C++ libraries for microcontrollers. So as I mentioned, the first thing is that it helps you collect custom data sets. A lot of times in the machine learning world, as you're learning this stuff, a professor or teacher just go to Kaggle, grab a data set, tinker with that, and you're good. And when it comes to creating something that's useful, the reality is you often need custom data. So part of the thing that Edge Impulse does is it helps you collect that, organize that data, and get that into a project so you can use it. Even if you start with a pre-trained model from a known good data set, you often find you need to do some transfer learning to get the model to do what you need, because everybody, like what we find is like the vast majority of people want that customization when it comes to creating a project for their own needs. The other thing is that it helps you design and develop your models and your algorithms. That includes DSP front end for things like time series data, excuse me, audio data, time series, so things like heart rate or EKG, ECG data. You often need to do things like fast Fourier transforms to get it into something where a model can then make better decisions. Now, you can have like crazy large models that figure out what to do with it, but oftentimes using a little smarts ahead of time to say, oh, let's put this into FFT because FFT works better for identifying certain types of sounds. So the output of that, you get your frequency components and the model works better. So you save processing time, you save memory, rather than letting the model figure all of that out on its own. And then, of course, there's any good ML system, ways to test your model. That includes like a holdout set, in addition to being able to deploy your model to a device, an embedded system or Linux device, and testing it in real life. And you can get some metrics from that. It also helps you deploy. That means packaging it in a library or a pre-compiled firmware and then shipping it off to your device so you can include it in your application when you go to deploy your TinyML device to the field. Finally, the one of the big parts of this is that we have webhooks and API, so you can script all of this to help with, you want to integrate it into ML ops. I don't know, does anybody cover ML like Edge ML ops? That's like kind of a new thing we're discovering recently. I don't know if anybody's like looked at that. I know VJ has a course on it, but it's basically taking machine learning operations and going, okay, how do we apply this to the edge? And most of it looks like ML ops, but the tricky part comes into right here where it's trying to do things like over-the-air updates. If you're running Linux, in my experience, it's pretty easy to like stop a process, update new code, and then restart that process. Like having an operating system is great for that kind of thing. But when you start talking microcontrollers and embedded systems, that becomes a lot trickier because there's no operating system, there's no processes. You have to shut the whole thing down, reflash the firmware, and then run it again. And this happens when you want to say, I've got new data or something happened to my model, and I want to push a model out to hundreds or thousands of devices. So you can imagine, think IoT, right? We've got hundreds of thousands of sensors in the field, but they're running edge AI, they're running models on the devices, and we go, something changed in this operating environment, or we found a bug in this model. How do you get models out to all of your users? Now, the classic way is like, you have to tell the user, okay, take this device, plug it into this port, this USB port on your computer, run this application we gave you, and it up to like, oh my goodness, you can count on like 1% of users actually doing that. So doing OTA or over-the-air updates helps you push firmware. It helps maintain security. You can get model accuracy, and you can complete that edge ML ops loop, but it's very tricky. So Edge Impulse doesn't do OTA, but we plug in nicely to OTA providers like AWS, Greengrass, Goliath, Particle. So you can use webhooks to say, oh, there's a new model available or on a schedule. Just go and grab that model and then do the OTA push to the supported devices. And that's why that slide, that's why that circle is in little dash marks. It's like, we don't really do OTA, but we help support platforms that do. Once it's on the device, we have some things on there to help you. So we've got a big library. Once you deploy it, it contains your trained model. In addition to the trained model, it contains all the DSP code you might need for pre-processing and some image manipulation stuff as well, even if you don't do as much pre-processing with images. So we call that an impulse, the thing that gets packaged and shipped to the end device. That is both that pre-processing and the trained model side, and any like maybe anomaly detection, but I'm going to call that a model. And so that gets packaged and shipped to the device. So your engineers or students can write your application, write applications around the model, around this library, and it makes it really easy. There's like a couple of function calls. It's just like you feed it data, it does the pre-processing, and it spits out model results or inference results on the backside. And then you can do something with that. The basic form is in C++. There's also an Arduino wrapper, and I'll show you that in a minute, and ways to get it into things like Linux or a Docker container or TensorRT for your Jetson boards or for your graphics cards. We are also working on, this isn't announced yet. Sorry, we mentioned that we were working on this. It is not been released yet. And that is a form of model monitoring. It is something we're working on so that in that embedded code, you can see how well your model is performing so that, you know, if you're seeing some sort of model drift, you can trigger a reflow to say, hey, capture new data, retrain the model, and push that model. So you can complete this loop completely automatically. So that's where we're moving towards, is just completing this entire ML ops loop. As I mentioned, one of the things you can do is we have an API endpoints for controlling all of this. So if you want to script all of it on the backside, you absolutely can. The other thing is you can push new samples using an API endpoint. So, hey, I grabbed a new audio sample. Let's just shove that off to my Edge Impulse project over the internet. So all of this is possible. The other thing we do mostly for enterprise customers is support of various buckets, data lakes, think like AWS, S3 buckets. A lot of enterprise users keep their data in there because they use the AWS tools to store, maintain, curate, and clean that data. And then when they're happy with that, they can automate a process to get that data back into Edge Impulse. So hopefully this gives you an idea of what Edge Impulse covers, kind of where some of the borders are, and where we play in the industry for helping Edge AI and TinyML. At this point, we definitely have over 100,000 developers with over 200,000 projects. I would say a fourth to a half, probably about a third of our developers are actually like university students and hobbyist tinkers, people who just want to learn this stuff. We have a lot of universities and students using us because it's a great way for students to get an introduction to ML. We find that a lot of people coming from the embedded side understand coding, they understand the embedded systems, but the ML side can be a little tricky, and we absolutely help with that. Even if you have ML knowledge, this helps you get to the embedded side super quickly because you know how to do all the things in ML. Great, you've got your model. We also have things for like bring your own model. We've trained it in TensorFlow. Awesome. Or you've got an Onyx model. Great. Just shove it into Studio and we will do all the optimizations and conversions and get you a wrapped up C++ library. So we make both sides easy, and students really enjoy that. So I know a number of universities are using us to help teach TinyML and embedded AI. We've got a number of partners who use us. We've recently signed on NVIDIA as our partner, and I'll talk about how we're integrating with Tau and mention a little bit about what we're doing with Omniverse and how we're integrating with NVIDIA. That's not just, oh, we can deploy to graphics cards. There's actually some really cool things that NVIDIA is doing. I enjoy this chart, especially for people who don't quite understand the terminology around like MCU, MPU, GPU. So you all probably know this stuff, but I found this one pretty helpful for describing to people like, oh, where and why would you want to deploy a particular model to a certain device? Or on the other side, like, oh, you have a model or you have an idea for an application. What kind of hardware should you probably consider using for that application? And the low-end MCUs are like your ARM Cortex M0s, M3s, M4s that run less than about 100 megahertz. That's like that Arduino Nano 33BLE Sense that kind of falls into there. I listed out some of the use cases at the bottom here. So time series is like most time series that are under like a kilohertz is what I'm calling it. I didn't have a great name for that. So like EKG, ECG, all that heart rate, biometric monitoring, things like weather data that might be like really slow. You only sample like once a minute or once an hour. So any of the like slow time series stuff, most of these MCUs can do classification on that, no problem with neural networks, because that stream is very slow sampling rate. And then you also have audio, which is usually above like 4,000 to 8,000 kilohertz. Sorry, 4,000 to 8,000 hertz. Sorry, I'm talking too fast, which means I need more coffee. That's how that works, right? So once you start doing like keyword spotting, identifying like, oh, there's a faucet running, or maybe this machine doesn't sound right and I need to do anomaly detection to notify its operators. I have found that image classification, object detection don't work pretty much like well or at all on these low end MCUs. You can do things like image detection with like 96 by 96 grayscale, which is like great for really basic toy data sets. Like I do like with the Arduino Nano 33, I've taught a workshop where you do rock, paper, scissors with your hand gestures. So like paper, rock, scissors, and it can kind of work with that, but not object detection. Most object detection models are just way too big for this. Edge Impulse does have this thing called FOMO, which is faster objects, more objects, and you basically divide up your image, and I've got an example of this in a bit. You divide up the image into a grid, and then you basically do image classification on each grid point. So you end up with a weird amalgamation of image segmentation and object detection, where you can kind of do object detection based on this like loose grid. So you can't get exact bounding boxes, but you can kind of know where objects are, and it works well for counting objects or doing like, oh, there's a person in the frame and about where is that person in the frame. So it works well. I've seen it work on the Arduino Nano 33, but man, you're talking like 96 by 96 and like it is like one frame a second. I would call it not usable. The higher end MCUs are things like your OpenMV, if you've played with that one, anything like your ARM Cortex M7s that are much faster. Those can handle most image classification, no problem. And you start to be able to get into object detection. You're just going to be very limited. And then, of course, you have your MPUs or like your CPUs in your laptops. Those are just brute force. They're not set up or really optimized for um, uh, neural network operations in any way, but they're so fast. You just brute force your way. No problem running object detection. I'm running an LLM on my laptop in CPU mode because I can. It's the Llama 3 8 billion model. And so like that handles it, it takes 10 seconds for a response, but it works. So it's just brute forcing it. GPUs, I love the story of GPUs because it started as like a way to display graphics and for video games and rendering images for like movies and such. That's what the graphics are meant for graphics. And because they're so good at doing single instruction, multiple data type of operations, people have discovered ways like, oh, well, we can mine cryptocurrency with them. They're really good. Like cryptocurrency is like great on graphics cards. And now we're running AI and machine learning operations because it's all this matrix operations, which most graphics is just matrix operations, and graphics cards are great for that. So I love that like Nvidia stock is now bonkers, not because of video games, but because of AI. Like not part of their like for when they founded Nvidia, they didn't think, oh, we're gonna like make we're going to be $1 trillion company because we're going to be in the AI business. That was not part of the story, but it is now, which is fascinating to me. But yeah, most AI applications that you like cloud applications are running on GPUs these days. So TinyML should be able to live on low-end device and not GPU. Otherwise, will I call it? That's a good question. The term TinyML, my understanding is a little bit owned by the TinyML organization, so tinyml.org. And so most of the time when I hear people talk about TinyML, they're talking about running it on microcontrollers, like really low end edge devices. When I use this is something we're playing with in marketing in Edge Impulse is like, what do we define something that's not a microcontroller, but still edge, right? I've got one of the Jetson boards over here, right? That's still an edge device. It's meant for like robotics or doing edge type stuff. It's still an edge board, like Raspberry Pi. That's still edge. So we're going with the terminology of like edge AI for something that's like not a laptop, not a GPU, not in the cloud, probably not on your phone, even though your phone is edge. I would call all of that like your laptop, your phone, your single board computers and microcontrollers. I would call that under the umbrella of like edge AI. Edge Impulse is targeting a lot of single board computers and microcontrollers. So microcontrollers, I think TinyML. Somebody correct me if I'm wrong here. This is where my head is at when it comes to like TinyML is generally ML on microcontrollers. And then Edge AI is like the umbrella term for anything like AI anywhere on the edge, not cloud, basically. Anything that's not running on the cloud. So I hope that helps. But because it's like edge AI, I'm including GPUs and things like NPUs, and NPUs are the weird ones because I love where this technology is going. We're making hardware specifically targeted at running neural networks in a very optimized way, both energy efficient and very fast. Um, I got the Google Coral Micro, which is like the little bitty microcontroller. It's like no, I don't think it's STM. It is an ARM Cortex like M7 running with a TPU coprocessor. So that's a version of a neural processing unit or NPU. And I could do object detection like with actual bounding boxes at like 10 frames a second. Okay. It was like 256 by 256. And so now we're actually getting to something useful on small, low power devices. ARM has also announced like the U55, U65, U85 cores, which are going to be co-processors that are optimized for neural network operations. And we're just now starting to see silicon roll out. I think like the Renesas RA8, somebody correct me if I'm wrong on that. And then Aleph has some boards that includes these ARM Cortex U55 cores embedded in the same silicon. So you can now send off neural network jobs to these co-processors, and it just crunches through the numbers in a very fast, low power, efficient manner. Like chips, I'm talking chips that are like 7 millimeters by 7 millimeters. I saw a demo on one of these embedded conferences. It was the Aleph board, and they were doing object detection, like maybe 256 by 256, like a 10, 20 frames a second on this like little bitty chip. So I'm excited where that technology is going. NPUs have also been scaled up to like the size of graphics cards because they just replicate it and make them more parallel. And you can end up with these giant graphics cards. So if you go to like Google Colab and you click down the thing, instead of GPU, you could say run on a TPU, and you usually have to pay for it. But that's just these like racks of NPUs, these TPUs that are just in there on the servers, and you can just run it on those instead of GPUs. I didn't include a lot of things on here like LLMs, other uses of AI. These are the big four use cases that I generally see in edge AI right now. Of course, that's going to grow, and of course, that's going to change. So, eventually we'll see LLMs on microcontrollers because technology just grows, and that's where we're going. Don't know a use case yet, but I'm sure we're going to get there. So let's take a look at Edge Impulse. Any questions about like broad overview so far? While I take a sip of coffee. Oh, excuse me. So I'm going to take a quick tour of Edge Impulse. Feel free to scan this QR code. It just leads to this URL right here. This is a project that I have made public. You're welcome to, if you start an Edge Impulse account, if you don't already have one, you can just clone this project, and it's a keyword spotting demo. I mean, it is like bare bones. I've got yes, no, noise, and like the other ones. This is from Pete Warden's TinyML keyword data set. It's like 10 different words. And so we just created this toy data set that you can download, you can play with. I put it in this project. And it's, yeah, yes, no, other words, and some background noise. And so this is where you can upload your data. In Edge Impulse, we can upload data here. That includes, oh, I just have a bunch of WAV files. Let me just ingest it. You can also connect a board. If it's a supported board, meaning Edge Impulse has written firmware for that particular board, you can connect that board and collect the data. Like a little thing appears over here, and you can, collect the data, like say your keyword, it uploads it. It struggles a little bit with like images and some larger files, but for time series and audio, no problem. Once you have your data, we can create an impulse. And like I mentioned, that is a combination of your signal processing front end or pre-processing front end, followed by your model. Right now, we only support one model and like anomaly detection. We're working on ways of getting like, oh, give me two different classification models. You can include multiple processing blocks. So you could have like an MFCC with just like a basic FFT or spectral analysis, and that can go into your classification. It's just a different input. So once I've set these, I can go to my processing, and this is where I can define any sort of processing parameters. So I can change how the FFT works. And if you're not familiar with Mel frequency cepstral coefficients, that's basically you take the FFT, you filter it with these like logarithmic filter banks. So you end up with like this logarithmic frequency zones basically, and those were chosen specifically to mimic how the human ear works. So MFCCs are great for processing speech and getting the shape of that waveform out. Essentially, it's trying to mimic what human ears interpret, because we have like all these little hairs in our ear that vibrate at different frequencies. So we're basically doing this biologically. After those filter banks, it goes through the discrete cosine transform, and you end up with something like this. So here's your basic waveform, your time series, and then here's what the output of the MFCCs looks like. The lower the number, the more it describes the overall shape because of that DCT, and then the higher describes the like little details in the shape. So oftentimes you can drop higher numbers in the coefficients, and it still works because it's just details. But sometimes you need them. It's like resolution in an image. The fun thing is this is now a two-dimensional array, which looks like an image. So we could actually use image processing techniques image classification techniques in order to classify sounds, or in this case, keywords. So we end up using, oh goodness, CNNs, convolutional neural networks, more coffee. So we end up using convolutional neural networks like you would for any image. And that's what gets fed into the neural network. So once you're happy with the pre-processing, you can go into your neural network or your classifier. And we actually support a number of different classification and regression techniques. The big one, of course, is neural networks, dense neural network, convolutional neural networks. But we have just released support for classical ML, so like XGBoost, random forest. So there's a number you can include in there. Those are all in the enterprise version. We have a number of enterprise customers who want to run on like super tiny microcontrollers, and they're like, we want to classify sounds. And a lot of times those classic methods actually work really well, or well enough for their needs, and they just don't take up as much memory or processing time as things like neural networks. In here, you can manipulate all sorts of hyperparameters. There's also expert mode. Oh, they're going to make me clone the project. Okay, so let's pretend I've cloned it. This is the same project. It's just on my account end rather than the public version. So if you're familiar with Keras, I have done this a number of times for my projects where I will go into Colab, I'll try something out and I'm like, okay, I need to take it to the edge. So I'll just like copy my training code that was done in Keras and just paste it in here. And as long as you understand what's like what some of the parameters are coming in, like how do you get your data, you can just write Keras code and you can just train. So once it trains, yes, switch back. Once it trains, you get your confusion matrix out and you can see like 90%, 89% is not great, but good enough. We need a lot more data to make this work. Here's an example of Shawn's comment. U55 new, oh, sweet. Yeah, thank you for defining that. Yes, the U55 is really fascinating. I'm super excited for this to start hitting more silicon. I'm stoked to get my hands on one and play with it because it means we can start doing machine learning stuff very fast, very efficiently on device, on silicon. So yeah, thanks, Marcelo. That's a great comment. Yeah, getting specifics, I couldn't remember those specifics off the top of my head. I just know they're super cool. So once you're happy with the machine learning model, as you can see, this is just a basic one-dimensional convolutional or 2 layers of 1D convolutional layers. And there's just 1 layer of dense neural network to do the actual classification. It's actually a fairly simple network. It's just we can run it on microcontrollers now. Once you're done with that, you can go into model testing. I didn't click the classify all, but it would just classify these for you and give you a result. It was like 86%. Good enough for this demo, but I would not feel confident deploying something with just 86% or deploy for like a scientific paper or research paper. Yeah, if you can prove like 70%, a lot of times you can still get published if you prove something new and novel. But for deploying, like if I was going to deploy this on like an Alexa to do keyword spotting for me, 86% is abysmal. Like that would be like a terrible user experience. From what I've seen, you actually want to get this to like 99.99% accuracy with very few false positives, very few false negatives to be a useful keyword spotting system. Is Edge Impulse the only way to implement ML algorithms on microcontrollers? No, definitely not. It's built around, it's a good question. It's built around TensorFlow Lite for TensorFlow Lite Micro, used to be called TensorFlow Lite for microcontrollers. So there's the like, I'll call it the hard way to do it, where you train it in like a Colab or Jupyter Notebook. You can train your model using TensorFlow and Keras, and then you can call a number of specialized commands, and it will take that model, convert it to TensorFlow Lite, which is like a binary file that can get streamed into your memory chunks at a time, and then you convert that to essentially C++ code, and that or it converts it to a binary, and then you call that using the TensorFlow Lite micro library, and it reads it in chunks at it. That's a flat buffer, if I remember. It reads it in chunks at a time, and so basically it reads it into memory and uses it. But it's just a bunch of commands. We also have some unique optimizations to get the size down even smaller than what TensorFlow Lite micro can do. But there's a number of ways to get it onto microcontrollers. There was an Adobe project. If somebody knows the name of it, please throw it in the chat. Where you could get it onto microcontrollers. I haven't played with it. I believe that there's something in MATLAB where you can do it, but you basically have to write all your code in MATLAB, including your application code, and it will convert it to a binary, or it will convert it to like generated code that's like impossible to read and debug, and you don't really include that into into your application. Like you have to write the application in MATLAB code. So if you're going to do it without Edge Impulse, then like TensorFlow Lite Micro is probably the way to go. Edge Impulse just makes it easy. It's visual. It's a great way to like keep your data in one spot. So many ways to do it. I will mention that what I'm showing you here can be done with the free version of Edge Impulse. We have like as soon as you sign up, you're gonna be put into like an enterprise trial. It's a marketing way to get people like, oh, try the enterprise features, and then your account just gets converted to a free community tier. So you're limited to like 20 minutes of training time. Like none of the enterprise features about like that ML ops stuff is available, but it still works very well. And like in my experience, I've taught many workshops. I've taught a couple of courses where I just use the free version, and it's perfectly fine. Is it possible to use Edge Impulse with multimodal dataset? Somebody remind me what multimodal dataset means. Oh, there's the MATLAB link. Yeah, thanks for yeah, generating C code. What is a multimodal dataset? Is that like data that has different like axes on it? Yeah, I actually don't remember that one.
It is a database from different sources, like
Um,
image,
Sensor
audio,
fusion?
etc.
Sensor fusion. Yeah, I mean sensor fusion. So definitely yes to sensor fusion. For lack of a better term, like if you're familiar with like ragged tensors, where like the tensors all have like different sizes or dropped data. It does not work with differently sized data. So you can do like sensor fusion in the sense of like as long as you have like the same sampling rate, it will work with that. But that's like, oh, I've got two different microphones. Yes, we'll work with that. But if I've got like microphone and vibration data, if that's the multimodal, then I don't believe it's going to work out of the box with that. You can probably do some modifications to make that work, but generally you have to assume like same sampling rate if you're talking about time series data, if that makes sense. In your project using audio data, Edge Impulse doesn't offer transfer learning directly. Instead, I have to create spectrogram myself and upload them to Edge Impulse to use. This might be because Edge Impulse uses power spectral analysis rather than images. What do you think about this? We do have transfer learning, but yes, you do generally still have to go through the pre-processing stage of whatever that DSP side is. So it's like, oh, I'm going to do transfer learning because we have a transfer learning model for keyword spotting, but you still have to go through the pre-processing stage because the transfer learning model, the pre-trained model expects data coming in. I think the way we've trained it is it expects spectral analysis. So you still have to get spectral, like your MFCCs or your MFEs or your FFT or spectrograms from the raw time series audio into that format so that the model can accept it. So I don't quite know how to answer the question. It's because of the way the model expects it. So yeah, we do have transfer learning, but yeah, you have to get your data in a format that the model expects. And if that's spectrograms, then yeah, you got to get your data into spectrogram mode. So yeah, that's the way it goes for now. In creating your model, what are the factors you have to take into consideration to choose the algorithm? Edge Impulse, I'll answer it from the Edge Impulse perspective. Edge Impulse tries to guess at what you're trying to do based on some of those applications that I mentioned, like, oh, you're working with time series data that's not keywords or not audio, or you're working with audio that's not keywords, or you're working with keyword. So we'll try to recommend something based on what kind of data you have in there. So we do some smarts, be like, oh, this looks like audio data. Well, we recommend MFE or MFCC. When you go to choose your impulse, if you choose a processing block, it's going to star the ones what it thinks. So it gives you some recommendations. Other than that, and then like based on the recommendation, it'll say, oh, that's an MFCC, and then it'll recommend like, oh, we recommend classification, and because we see it's audio data, then we're going to do a 1D a dense neural network, or sorry, a 1D convolutional neural network. So it tries to get you there. It's like, I call it like the 80% best guess, and then you can modify from there. So trying to choose the algorithms, it's a little bit up to you. Like you have the ability to go in and change it as you need, but we try to get you there based on use cases. But factors to choose the algorithms, man, that's like a master's level class in like machine learning or processing to figure out like, oh, is it two-dimensional data? Well, maybe a convolutional neural network, or maybe an LSTM. So it's like machine learning to discover which of your algorithms work best. And there's like really cool trees and diagrams out there on the internet. Be like, oh, I've got this type of data. Maybe you should use a random forest, or I've got this type of data. You need a convolutional neural network. So there's some things out there to help you, but we try to take the best guess and give you a what we call sensible default, and then you can change from there. Does it need fast enough internet connection? Is there minimum specs to run Edge Impulse? What if we run this on a Raspberry Pi, for instance? Okay, so because it's all cloud-based, what I'm showing you is all cloud-based right now. So it like as long as you can load websites, Edge Impulse will technically work. The tricky part is when you try to upload data, and that depends on if you need to upload like tons of image data. It's going to take a while with a slow internet connection. That's just the like trying to upload data is rough, because Edge Impulse doesn't run locally on any of your systems. It's like, yeah, it's all reliant on internet to make that happen. So running Edge Impulse, it doesn't run locally, it runs in the cloud. So once you get the data into Edge Impulse, yeah, you just like click buttons and everything else runs on the cloud. Minimum specifications, I'm sure a Chromebook would do it, no problem. Like I could do all this from my phone. It's just getting data onto your project's the tricky part. What if we run this on a Raspberry Pi? You don't. Sorry, it's all cloud-based. You can run inference on a Raspberry Pi once you're done with the project. But yeah, that's a good question. Yeah, Edge Impulse is not running locally on my machine. It's all running in the cloud. Yeah, it's fairly complete. It tries to give you that end-to-end system for uploading data, like doing pre-processing, training, deploying, all of that. What are the tools to deploy? Very good question, and that is where I was going next. So once you're happy with the way it's trained, you've tested your model, we can go down to deployment. And there's a bunch of options here. I deployed to an Arduino because that's what this project was for. But there's also the main one I would say is a C++ library. And that is just a like pure C++. We try to do, I don't think it involves like any external dependencies. It's like pure C++. So it will run on anything as long as you have a C++ compiler for it. You have enough memory on your system to run the model and pre-processing, and you're okay with the latency, how long it takes to run inference. So as long as you have those three things, it will run on anything. The Arduino library just takes the C++ library, wraps it, throws those like 3 files in there with some Arduino examples to make it into an Arduino library. So you can just load it in. The C++ library is amazing because it will you can bring it into like any IDE. It just takes some time to link to it and make sure the compiler picks it up. Like expect to spend a few days fighting with like your IDE to make sure it's properly linked. There's a whole bunch of other things in here. Like we work with BrainChip, the CMSys pack, for like your STM32 or like, yeah, your STM32. We're working on the new Ethos U, so we do have support for that. So once those start hitting silicon, yeah, we've got the U55s that Marcelo was talking about, ready to go. We integrate right into IAR, so it's just like a pack. You just install into IAR, and it's like got all the linking for you. Particle library, so lots of different libraries. TensorRT. There's a Linux binary that will run. It's a .eim file. It's basically a binary. It's a process that runs in the background, and then you can talk to that over a couple of hooks. So that's, and I think it's like Linux only. So it's great for like Raspberry Pis or Linux machines where you just like, oh, spin up a process in the background, and now I'm going to talk to it. And we've got Node, JavaScript, and Python and Go libraries where we have examples and libraries to like you can wrap that and you can talk to that process, no problem. We also have a bunch of pre-compiled firmwares that include your model that has for a number of boards. Fine for demos, but if you can't really modify the code to create your own application around, which is why I almost always go for that C++ library, Linux binary, or the Arduino library. The new thing, one of the new things in the last year, we can spit out Docker containers. So anybody who like wants to run this in a cloud application or a local server, absolutely, just be like Docker, done. Right now you have like an HTTP interface, and it's doing prediction serving for you. Okay, cool. So I hope that answered that question. So once you get it in there, I will show you. I've got Arduino in here. I've loaded it in. It's just, I included it. This is one of our example demo applications that's doing keyword spotting. I quickly modified it to turn on LEDs whenever it sees yes or no. If you give me just a moment here, I've got, Marcelo, since I can see you, can you see me holding up this board? Yes, okay, cool. And you can probably see my prediction results down below. Yes. No. Yes. There it goes. Yes. Oh, come on. Yes. There it goes. It's lighting up my green LEDs and red LEDs whenever I say yes and no. Yeah.
Working.
All right. We got it. We're good. Because I couldn't see the LEDs. I'm like guessing here. I'm looking at the prediction results on the side. So yeah, that's an application where it's included as a library. And I just, this is mostly Edge Impulse wrote this, but then I just modified this application code in order to make it do something. In this case, toggle some GPIO pins. So what do I have left? What do I have left? Like 15 minutes here? Or no, I'm soon, right?
Yes, you can have it. Yeah.
Okay. Can't remember. Like my stop time was like 8:35, I think.
Yeah, but only for you to know, I have the Professor Jose is here, Jose Antonio, and what he'll do after your presentation is exactly a complete hands-on.
tutorial.
Yeah, will be great. So everything that you talk will be good for in the sequence. So take your time, Shawn.
Okay, excellent, excellent. Okay, how easy is it to port new hardware to Edge Impulse? For example, relatively new boards using a chip called these chips. It has a TPU because the platform is new. There isn't much software to support it. Okay, that's a good question. So getting a C++ library out to do inference and then bring that into a compiler for a board, not that difficult. Few hours, maybe a day. If it's like new hardware, like a TPU that we don't already have supported, that's going to be a little tricky because I don't know the steps. Like when I was working with that Google Coral Micro, I had to take the TensorFlow model file the TensorFlow Lite model file, and then shove that into Google's tool in order to get a binary that then gets loaded specially into the TPU. So that's what I had to do. Even though if I train stuff in Edge Impulse, I had to get that TensorFlow Lite model out, which you can do. It's on the dashboard page. That will, like, you still have to go through their tools to do it. If you want to integrate that into Edge Impulse, we have something called custom blocks. We have a custom deployment block. So you could create that script to grab the TensorFlow Lite model or whatever model file from your project, run it through whatever build process you need, and then it can also spit out like a zipped C++ and binaries for you. So you can. The reality is for like single use, unless I'm like putting that in a whole edge ML operation kind of thing, and I need to automate it, I just grab the TensorFlow Lite micro or the TensorFlow Lite file from my project and just shoved that through the compiler manually. So I wouldn't say it's easy. Probably about the same as like trying to get it to run on any new hardware that's not already supported Edge Impulse. Do we need a cloud like TensorFlow to load data for learning using TinyML so we can use it? I'm not quite following that one. You need an account on Edge Impulse because Edge Impulse is all cloud based, which is doing TensorFlow stuff in the background. So I would say like, yeah, you need a cloud account. And then for prediction, you get like we have ways to test it, but for prediction, you have a C++ or a model file that you can like load into anything. I hope that helps. Since EI recommends some learning blocks based on the uploaded data, is it possible for EI to observe different classes in the data acquisition phase and label them to avoid uploading labeled data? Interesting. We have some smarts that will help with, we have some auto labeling tools. So I don't know if that's quite the same. We do something where it's like, we do some deep inspection of your data. So we try to avoid duplicate data. So if I've got like pictures and it's like literally the same picture, you can set it to reject pictures that are literally the same, that have like the same, like it's like a hashed signature. And so it'll just reject them. So we can avoid duplicate data. We also have some auto labeling tools using like YOLO 5, I think. And so it's like, oh, I'm trying to do labeling for object detection. You can just run it through our auto labeling and then tweak from there. As far as I know, that's it. So I don't think it's exactly what you're talking about with like avoiding uploading data. Hope that helps. Do the TinyML examples in your Coursera course only support Raspberry Pi? In theory, they should. In theory, they should work for the Raspberry Pi 3. I think the problem that we ran into, correct me if I'm wrong, is that the Pi 3 was a 32-bit system. The Pi 4 was a 64-bit system. So if you're using the like .eim models that you download from Edge Impulse, we don't support 32-bit processors. So you're going to run into a problem there because it. Or wait, we do support 32. If we do support 32, you have to make sure it's like a 32-bit OS and a 32-bit processor. So it might work. It's just I didn't cover it. You can get it to work. And even if it's not the .eim, you can always get the C++. You can always get the TensorFlow Lite stuff. So you can get a Pi 3 to work. It's just like it might not work like out of the box with Edge Impulse. What about the Pico? Yeah, we actually support the Pico. It's a C++ library, and one of our deployment options is the Pico. So if I go here, There it is. So the RP2040, it's right there. So yeah, we supported either as a precompiled binary or just a C++ library that you just, God, the the Pico build system is so good because it's just all CMake. It just links it for you with like a couple of lines. Cool. I'll quickly go through these, what's kind of been new in the last year. We've announced FOMO AD, which is using FOMO for anomaly detection. And this is looking at an image and it divides it up into those grid points, like I mentioned with FOMO. And you train it on known good stuff, and anything that's not known good, it flags it for you. So this is like cracks in cement. So you could like put this on a car and look for problems with cement, or things on an assembly line where it's like stress marks or fracture lines or something that doesn't look right. It can identify not only that there is an anomaly, but where it is in the image. You can see it highlighting things that were not part of the training batch. We also have an integration with Tau. Tau contains a collection of pre-trained models that you can then use NVIDIA's tools for doing transfer learning with those models. But what we do is we say, oh, instead of using NVIDIA's tools, let's go to NVIDIA, grab those models, and then we use Edge Impulse for training. NVIDIA wants you to deploy to a graphics card because that's where NVIDIA makes their money. But we've worked with NVIDIA to say, let's use Edge Impulse to deploy to anything. So you can now have all those deployment options from an NVIDIA Tau model. So this is part of the transfer learning thing where it's like, oh, let's use off-the-shelf models. Now we deploy to microcontrollers. Most of those models are like object detection models that might struggle on microcontrollers, but the theory is there. But we're helping people deploy these to any number of devices. I've also been helping lead the Python SDK team. This is where we are wrapping up all those API calls to make Edge Impulse easy and more usable from within Python, so you can script a lot of this stuff. Right now we have the ability to like, oh, I've trained a model in TensorFlow, I've trained a model in PyTorch. Let's take that, throw it over to Edge Impulse, and we can profile it, meaning we can get what we expect it to run on. I can define a target like a Cortex M4 target, and it will give me like estimated RAM usage and flash usage and latency. You can also deploy it, like this is like the whole BYOM thing. I can take a model, give it to Edge Impulse, and give me back C++ code. So this is just useful for, I've got a model, let's train it. We're also working on scripting individual parts of that whole learning process. So you can also use it to like upload NumPy or just raw data. So I've got it on my computer. I need to script it to get it up to Edge Impulse. And we do upload and download data that way. All right. So I think how much more time do I have left, Marcelo? I thought I was at 8:35.
Yes, we are on time, but
Okay.
I talked with Jose, and you can go and have about 5-10 minutes to show the project some questions, and it's okay.
Yeah. Two quick projects, and then yeah, feel free to type in questions or if you have any questions. Two quick projects. I made an AI toaster not last year but the year before, and that uses regression to predict. It uses gas sensors to predict. Oh, come on. So I have gas sensors up here that smell the toast basically, and I used a regression model to figure out how long until it got to burnt. And then like 42 seconds before burnt, it would pop them to get perfect toast. So just a ridiculous way to use a toaster. In addition, I've also used reinforcement learning to do a balance beam. Couldn't quite get it balancing because the process of doing the reinforcement model was too slow, which is why part of the reason I'm so excited about these like TPUs. Yes, that's the smell of COVID, exactly, like smell when something's done. But I used reinforcement learning and had a balance beam teach itself to swing itself up, right? It's the first part of this. It's like do the swing up, learn to do swing up on your own. So that was a fun project because reinforcement learning is weird, but we're getting there with robotics. Yeah, thanks, Marcelo. Yeah, it was a fun one. It was like how to do regression. We're getting to this point where we can use virtual worlds like Unity and Omniverse to do virtual simulations to create synthetic data. I haven't personally played with this, but I know some of the Edge Impulse folks who have. This is new and up and coming. Like, let's put stuff in a virtual world, both for reinforcement learning as well as like, what do things look like? Or there was somebody doing fall detection where they would just like knock over a virtual character and use that to collect data about what does a fall look like. This is very helpful for like elderly care. Fun magic wand projects for people doing magic wand duels, smart HVACs. Can we do people counting? Matt Kelsey at Edge Impulse was doing bee counting. This is where the idea from FOMO came from. Rather than trying to get bounding boxes, like, can I just quickly count bees? in a small package that is battery powered. Posture monitoring, somebody had this set up to say, oh, do I maintain good posture? And it would change based on how they were sitting. Smart recycling bin. This was a fascinating one because it wasn't trying to identify objects and their makeup by looking at it. It would do it by sound. So this person would throw it into the bin, the sound the object made when it bounced off the acrylic on the side would identify it as plastic, glass, or aluminum, which was actually a really cool way to think about like, oh, how can we identify different forms of trash or recycling? Plant health monitoring. Can we identify spots on leaves? Can we identify diseases? This was a funny one where dog barks were identified and the person had recorded their voice to tell their dog to be quiet and it would play it when it identified a dog bark. So that was a fun one. Can you identify snoring? It wakes you up or causes you to move. So here's some other good ways to get started. Any of the resources that the TinyML4D group have, very good. The TinyML cookbook is a good list of like projects and ways to get started in this, both using Edge Impulse as well as the TensorFlow Lite micro. If you're just getting started, as much as I love that TinyML, that first book that Dan and Pete Warden made, if you want like projects more hands-on, this cookbook's really good. That first TinyML book is like out of date because it was using TensorFlow 1. It's really rough because like none of the commands work anymore. So it's a good book, but it's a little out of date. This cookbook is very, very good. I've got my course on Coursera, and then there's the Harvard course on edX, and I'm sure there's some others that I'm missing out there. And I think that's everything from me. So I appreciate the extra few minutes to go through these. Any last questions before I hand it back over?
Thanks a lot, Shawn. Fantastic presentation as usual. Thanks a lot.
You're welcome.
Yeah, I don't know. But let's see. I think that you answered the great majority of the questions, no, during your talk.
I did. I tried to have the chat up and like was hitting questions as I go. Yeah. I've learned from the internet streamers, all those gaming streamers where they can like just like they're like playing a game and doing something. They're just talking to people, answering questions on the side. I'm like, okay, I love the flow of this, so I'm just gonna try this for like webinars from now on.
No, fantastic. Thanks a lot, Shawn. No, I remember all the folks that we have the Discord. No, so so guys, you can also continue putting questions there. I can help you, and and also we can send to Shawn to answer for us. Shawn also is there in the Discord. So
yeah, I'll make sure. I usually keep Discord down because I've got like I'm in a number of channels and it's so distracting sometimes. But I'll make sure it's up today, and I'll peek into that channel if anybody has more questions. You can just tag me too.
Appreciation. So
yeah, thank you.
Thanks a lot, Shawn. Thanks for your talk. And now, in fact, we will continue now with a lot of fun hands-on stuff, and also using this great tool that is Edge Impulse Studio. And I must tell you, Shawn, in name of the academia, and we using in the university, we use Edge Impulse Studio. The students use is a tool to help us to teach machine learning, deep learning, and also it's easy for the students to understand what's deep learning is from data to the deploy, and also for their projects. So we saw several fantastic projects in helping and going straight to the AI for good in the medical area, agricultural area, and Edge Impulse do a fantastic job for the university community. And I would like to thank you in name of Edge Impulse Studio about that. Okay, thanks a lot.
Yeah, thanks for having me. This was a lot of fun and great questions.
Yeah, thank you.